So two events A and B are said to be independent if probability of A intersection B is equal to the probability of A into probability of B. This was for the two events. We also saw for the three events. So three events, there are two cases. They are pairwise independent or they are completely independent, which is also called the mutual independence of three events. So mutual independence of three events A, B, and C is defined as they are pairwise independent, like probability of A intersection B is probability of A into probability of B. Probability of B intersection C is probability of B into probability of C. And probability of A intersection C is probability of A into probability of C. Also with that, there is probability of A intersection B intersection C as probability of A into probability of B into probability of C. And for the pairwise independence, we just take the pair of two of the events. And if it satisfies the condition for independence, then we say that the events are pairwise independent. These things we have seen, we have also solved two examples. Again, one example we will solve and then we will move towards the conditional probability. So, example. Consider the experiment of tossing an unbiased coin, of tossing an unbiased coin three times. Let AI denote the event that a head turns up on ith toss. Are the are events mutually independent? Example. Oh, sorry, solution. First one, let's write down the sample space for this. What will be the sample space? All three heads. Then we may have two heads and one tail. Two tails and one head. Or all three are tails. Now, what are the events? That AI is an event with head turns up on ith toss, which means if I want to define A1, then head should turn up at the first toss. So how many elements are going to be there? You look at the sample points where you have first head. So there are 4 head, 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 then head, head, tail, E2. What do we need now in this?
So, where H comes in the second turn.
So the number are
SHT, THH.
H and THT. Thank you. A3, the head turns up at the third position. So head, 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 then head, tail, head, tail, head, head, and tail, tail. So now what we need to check is, are they mutually independent? What do we call mutually independent? First of all, that the if the events are completely independent, then they are said to be mutually independent. So there are 4 conditions in that. You take pairwise intersection and the intersection of all 3 events. So first of all, A1 intersection A2. In this there is head, head, head. Then we have head, head, tail. Uh, no other possibility. Then A2 intersection A3, that is equal to head, head, head. Then tail, head, head. A1 intersection A3 is equal to head, head, head. The other one is head, tail, head. A1 intersection A2 intersection A3. What is this? Head, head, head. That's it. Now, let's find out the probabilities. Probability of A1, probability of A2, probability of A3. Then we will check the probabilities of A1 intersection A2. Probability of A2 intersection A3. Probability of A1 intersection A3. And the last one, probability of A1 intersection A2 intersection A3. Yeah. Probability of A1,
1 by 2.
Sir, 1 by 2.
probability of A2 is again 1 by 2. Probability of
3
A3
also.
is 1 by 2. Probability of A1 intersection A2
1 upon
is
4.
1 by 4.
1 by 4. A2 intersection A3 1 by 4,
Same for
and
A1 intersection A3.
the last one 1 by
1
8.
by 8.
So we'll check the conditions now. Probability of take pairwise intersections. A1 intersection A2, that is 1 by 4. And we see that it is also equal to probability of A1 into probability of A2, which is equal to probability of A1 into probability of A2. Probability of A2 intersection A3, which is equal to 1 by 4, which is equal to probability of A2 into probability of A3. The last one, probability of A1 intersection A3, this is also 1 by 4, which is equal to probability of A1 into probability of A3. And the last one, probability of A1 intersection A2 intersection A3 is equal to 1 by 8, which is equal to probability of A1 into probability of A2 into probability of A3. So first, second, third, and fourth. So from 1, 2, 3, and 4, so from 1, 2, 3, and 4. Events A1, A2, A3, and A4 are mutually
Independent.
independent. Next, a problem in statistics. A problem in statistics is given to three students, is given to three students, ABC, whose chances of solving, whose chances of solving are 1 by 2, 1 by 3, and 1 by 4 respectively. If all the three students, if all the three students solve the problem independently, solve the problem independently, What is the probability that the problem will be solved? What is the probability yes the student A will solve the problem, so probability of A is 1 by 2. Student B will solve the problem is 1 by 3, and probability of C is 1 by 4. What is to be found? Probability that problem will be solved. When do you say that a problem will be solved? If all three are solving independently.
A intersection B intersection C.
So
A
that
union, B union, C.
it is A union B
B
union.
union, C.
It is because that what we need is when you take A intersection B intersection C, it will mean that all three of them will solve the problem. It is a probability that all three of them will solve the problem. But the question is, it has to be solved. Can be solved by anyone, either A, either B, or either C. So the probability to be found is A union B union C. So here's the formula. Probability of A union B union C is equal to probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability of B intersection C minus probability of intersection C. Fine. Fine.
So plus
Sir, we need to
probability
add a
of
plus.
A intersection B intersection C.
Plus A intersection B intersection C. Now what can we do?
As all the events are independent, so A intersection B is equal to P intersection A dot P intersection B.
Yeah. So this will be probability of A plus probability of B plus probability of C minus probability of A into probability of B. Similar thing will be working for probability of B into probability of C minus probability of A into probability of C. Look, there is complete independence. I mean, all the three are solving it independently. So probability of A intersection B intersection C will also become probability of A into probability of B into probability of C. Let's just put the values 1 by 2 plus 1 by 3 plus 1 by 4 minus 1 by 6 minus 1 by 12 minus 1 by 8 plus 1 upon 24. So that is
29 by 32.
probability of A union B union C. 29 by 32. I think it is 3 by 4. Can check it later. Fine. Let's start with the conditional probability now. So very conditional probability. So we'll consider a family that will have 2 children. Okay. So a family having 2 children. So the sample space becomes either both of them are males. One is male, the first one, and the second is female. First is female, second is male, and both of them are female. Okay. So I will define an event A. Say for an example, A is an event. It says that both are males. So the event A will have both males, right? Now what I will define is so probability of A is actually 1 by 4. Now I will define B as B is an event. The first is a boy. The first is male. So the elements in B are going to be not first, I'll say one is a male. One is male. So the elements in B are this. So now what happens is I'll say that my event B is occurred. One of them is male, right? If one of them is male that I already know, then what will be? So in this case, what is the probability of B?
3 by 4.
It's not discussed. Say what I'm saying is B is occurred. B is occurred. Then what is the probability of A?
1 by 3.
1 by 3. Is everyone clear with this 1/3? So you should be able to give the answer if I call out your name. Hasnan.
So since there are three cases where at least one there is at least for one place there is male, so
Yeah.
we can say that 1/3.
Yes. So what is happening here is when the event B is already occurred, that is one of them is male, that is fixed, then there are only three sample points. Those are uh, these three. Okay. And then if I want to look at the event A, which is both are male, then the probability is going to be 1/3. So this probability is called the conditional probability. There is a condition that another event is already occurred and now I want to look at this event. Okay, so B is occurred and I'm looking at the probability of A. So this is called the conditional probability. There is a condition that one event has already occurred. Now, so how it is denoted? It is denoted by probability of A condition B. So what you look at, probability of occurrence of event A when B has already occurred. This is the probability, this is read as probability of A when B is occurred. Okay, so this is complete what you can say the idea of this conditional probability. Will immediately find out the formula. If I am looking at probability of A, how do you find out the probability of A? Probability of A is the number of elements in A upon number of elements in the sample space. This is our regular formula. So now what I'm looking at, probability of A condition B, which means that probability of A when B is occurred. What could be the formula?
P of A intersection B by
Probability
P
A
of B.
intersection B by PB.
So you are looking at the intersection, number of elements in A intersection B upon number of elements in B, which I can divide the numerator and denominator by number of elements in sigma. Okay, and then what we will get is, which will give me probability of A condition B is equal to probability of A intersection B upon probability of B. So this is the formula. So we'll write down a proper definition for conditional probability. So the suppose A and B are two events. This is conditional probability of A given B. Suppose A and B are two events defined on sigma. Suppose A and B are two events defined on sigma. then conditional probability of A given B denoted by P of A and B and is defined as probability of A intersection B upon probability of B. Example. A pair of fair dice is rolled. A pair of fair dice is rolled. If the sum of 8 has appeared, if the sum of 8 has appeared, find the probability that one of the dice shows 3. One of the dice shows 3. Yes. Okay, first of all, how many elements in sample space? Look, whenever we have large sample space, it is not expected that you write down the sample space explicitly. What are the number of elements?
36.
36. So I'll define the events now. The sum of 8 has appeared already. So what I will do here is B is an event that the sum is 8. Sum is going to be 8 when if there is 2 on the first die and 6 on the other. Then 3,
3, 5,
Yeah.
4, 4,
5, 3.
5, 3, 6, 2.
5, 3, 6, 2. No more possibilities. And what is occurred? A is an event which shows that one of the dice shows 3. One of the die shows 3. So what we need to find? Probability of A when B is occurred. This is something that we need to find. By our formula, probability of A condition B is equal to probability of A intersection B upon probability of
B.
B. So here A intersection B is equal to 3, 5 or
5.
5, 3. Let's do it. So let's put these in the formula. So probability of A condition B is equal to 2 divided by 36 upon B. There are 5 elements in B. 5 upon 36, which is 2 by 5. What will be the probability of B when A is occurred?
Is it
So
going to be
probability of A
probably?
intersection B upon probability of A. This
Uh,
is
the final
altogether
answer. The final answer is
2 by
probability of
36 by
B intersection A upon probability of A.
yes, sir.
So that will be 2 by 36 upon
2 by 36.
By 36.
2 by 36. So answer is 1. Both are not equal. Probability of A when B is occurred and probability of B when A is occurred. Okay. Just note this. I can give you this exercise. You can find out a condition when these two will become equal. Small exercise, you can think over it. A theorem. If A, B, C are 3 events, defined on sigma, with probability of B greater than 0, then probability of A union C condition B is equal to. Yes, anyone? Can you simply use the formula? That's all I want. You use the formula, just do some basic simplifications and tell me. Okay, what is your formula? Probability of A union C condition B. So this is probability of A union C is equal to probability of A union C intersection B upon probability of B. Can you simplify the numerator?
P of A.
Probability of, you can use the distributive law over here. So that will be A intersection B union C intersection B. I hope you know what is distributive law.
Yes, sir.
So now this is first set union second set. So that will be probability of A intersection B plus probability of C intersection B minus probability of A intersection B intersection C divided by probability of B. Separate the denominator. What will be the first term? It's not so difficult.
Probability of A intersection B plus probability of C intersection B upon
No,
P
no,
of
no,
B.
no, 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 not that way, not that way.
Probability of A given B. The first one.
Probability of A condition B
C.
plus
Probability of C given B.
probability of C given B minus probability of A intersection C given B. What does it look like? Can I say that it is similar to finding out probability of A union C? The formula, if you write down the formula, probability of A union C, what you will get is probability of A plus probability of C minus probability of A intersection C. So that condition part remains with each of them. That's it. Next, if A and B are events defined on sigma, are events defined on sigma, then probability of A complement given B is equal. Yes, anyone?
So 1 minus P of A condition B.
How you did that?
So I firstly simplified the given condition, right?
So
We use the formula. So the formula is A complement intersection B. So that comes out as P of B minus P of A intersection B.
exactly. So if you draw the Venn diagram for this, you have A, you have B. So A complement intersection B will be this part, which is nothing but probability of B minus probability of A intersection B divided by probability of B. Then you separate and you will get the required result. Fine. remarks. If A and B are two events defined on sigma, A, comma B are two events defined on sigma, then just a minute. And P of B is greater than 0. And P of B is greater than 0. Probability of A condition A complement. Yes. Yeah, wait, Manas. Aditya?
Yes, sir.
Yes. What is probability of A given A complement?
So 1 second. Probability of A upon probability of A complement. No. Wait.
Apurva
0.
Srivastava.
Yes, sir.
Yes. Probability of A given A complement.
Sir,
Yes.
is it 0?
Yes, exactly. Thank you. So you will have probability of A intersection A complement, which is already 0, numerator 0, so that's why answer 0. If A and B are mutually exclusive, if A comma B are mutually exclusive, then probability of A condition B. Khushi?
So 0.
0. If B is the subset of A, then probability of A condition B. Soham? Soham Navle? Akanksha?
Yes, sir.
Yes. If B is the subset of A, what is probability of A given B?
Sir, just a minute.
Sir, can I tell?
No, wait. Let me remove this Soham.
Sir, 1.
1. Fourth. Okay, mute yourself. If A is a subset of B, then probability of A given B is equal to. Now, Saurav, you can tell me.
Will it be 1 again?
No.
Um,
Roshri?
Probability of A upon probability of B.
Yeah. Probability of A upon probability of B. So when you take A intersection B, that will be simply A. Fine. That's it for today. The next lecture will look at the Bayes theorem. You can mark your attendance.